Hello everyone, my name is Venkata Krishna. I am third year BCA student from Sri Aditya Degree College, Bhimavaram. Today I am going to explain you about my project Waste Segregation Identifier. So the main aim of the project is to identify and segregate the waste to the class they belongs to. Just by the looking an image or just we upload the image of that waste item and it classifies that. So basically I have developed two models. One is the left one you see here. This one is the simple basic model. I used the Google Teachable Machine to develop them to train the model. I just gave the dataset to the Google Teachable Machine. It used a model and gave me the model. I did not train or anything. And on the right, you can see this is the waste segregation identifier. So this we have used the custom training model. So that means we have given the data set, we have cleaned it, and we have evaluated it and everything. We trained it and tuned the model multiple times. Here we used the in this model in this we used the MobileNetV2 model. It is a transfer learning model. So it is more we feel that is more accurate, but also coming to be frankly saying, both the models were perfectly accurate. The same identification of the waste items and everything was done. Both is perfect. We can use this Google Teachable Machine because it's a new technology. It makes the process faster and easier. So we don't need to conventionally train the model by and we have to clean the data. We have to adjust the images, everything, crop the images, everything, and have to split the data. Nothing in Google Teachable Machine. We just upload the dataset images. It trains the model and gives us the model in the TensorFlow.js code, and we integrate that into our HTML, CSS, and JavaScript file. I will be showing the code. Firstly, we can see the working of these models. So firstly, we see this simple, the model which is developed using Google Teachable Machine. So here we choose an image. For example, we take this batteries. If we open it, it just gives this. This is hazardous. So just process the image and tells which type of waste item it is. Let's try for another also. Let's try for organic type. We take this image and this tells this is organic. So you can see that. And also next try for another one more image for the recyclable category. This is recyclable. So you can open this website. I have hosted this website, so you can open this in. I will provide the link in the video in the description below. You can open it and you can access it with your mobile phone or desktop also. You can take any image and you can upload here, and it will be classifying the waste item to which category it is. So it works like this. So coming to our custom trained model, which also gives the exact results. Here we have the advantage. It shows the confidence score. So how much percentage it being recyclable or hazardous or organic. For example, you take the same images which you use for this Google Teachable Machine here also. So you take the battery waste here, you open it here. See, it processes the image. It gives this is hazardous. Confidence 99.97%. So it is mostly, definitely, it is a hazardous item. Next, we can try for the next image. We take the organic waste image. So this is organic. In the same way, we try for the recyclable also. See, the models, both models are perfect and they both give the accurate and exact results mostly. So we have to be trying and training to get the most accurate. Though no model is almost perfectly perfect. So that's why I have been training and training all this. So coming to here, I have hosted this both websites. This is I used the hosting and here I used the Hugging Face because to integrate the model, it been different as we have customly trained it. We have to import it using TensorFlow.js. Let's look the code behind both of these models. Firstly, let's look about this Google Teachable Machines model code. So if you see in here, we don't need much of the code as we don't need to train the model everything. It's a very little bit of code. This model file you can see here. So meta.json, metadata.json, model.json, and its weights. We get this folder after training the model in the Google Teachable Machine. We will get this type of folder which contains these three files. And we have written the index file for the HTML to the web application and also the style. The most important part is the script, JavaScript. In the JavaScript, we include that model. So for example, you can see here, see, this is the part where we load the teachable machine model. You can see here tm image.load model URL metadata URL. So here we load the teachable machine image model, and based on this, it works and it classifies the image whether it is hazardous, recyclable, and everything. So this is the code working behind, and we also use the asynchronous function. So this makes the website not to freeze, because while the model is predicting, if the user want to interact with the website, it may freeze sometimes. So to not freeze like that, the model predicts it does this work, and also user need to interact with the interface. We use it the asynchronous function logic. This is very basic one. So that's why it works very smoothly and easy to understand. So let's go to this our custom train model. So custom train model, let's see the code. So firstly, we have to take the data set. I have collected nearly 40,000 images for this data set, and after that, I have manually separated nearly like 20,000 images, and after that, I divided into each category 2,000 images. So I have to try. I divided into three classes into test, train, and validation set. Three sets I have divided. So all this where there's 2,000 images, one in 2,000, and next one in 1,000 like that. So each class nearly have 2,000 to 3,000 images, so that made this models more accurate and accurate, and we trained it on more huge number of data. So firstly, we put the data set, and I have manually splitted the data into test, train, and validation. So after that, we have to check and clean the data. So we'll check the data. So we have the file, like whether any duplicates are there, or is there any corrupted images are there. So we'll check this using the check and clean Python file. And if you want to note the count of the images, like how many images are for the each category, we can use it. It's not necessary, compulsory. And then next, most important one is that we have to use the train.python. So this is where we train our model. So here you see the model we used is MobileNetV2. So it classifies the image model. So based on that, it captures the image and everything. So coming to our model architecture, we used the transfer learning model MobileNet V2. This gives high accuracy and everything. We have been training it for multiple categories. We have divided the sample size and everything. So we get the lad as output of this model. We get the waste model.h5 file and best model.h5 file. So waste model is the last model after running multiple times. So we use this best model.h5. Before that, we evaluate. So we evaluate, we get the confusion matrix, and we also do the error score and everything. They all will be they show the accurate percentage. Nearly we got the 74% accuracy of validation accuracy, that too. So validation data set only gave me 75% of accuracy. So the normal training data accuracy was above 85. So based on that, I thought that the model was perfect almost. So we will be tuning it further and further, developing it based on the user feedback also. So lastly, and we have the app.va. So after developing the model, I use here the Gradio for the web application, because it is not easy to integrate this model into JavaScript like as in the before in the teachable learning model. So I have used here Gradio. So I use Gradio, and the same interface you can see here. The same interface I used it, the same CSS styling page and everything. But we used the Gradio application for the easy access, and also I used Hugging Face for the hosting of this website. So web application. So and everything. That's it. That's the app for this PY, and this is the code and everything. You can understand the logic here. Mainly the base of this program is that we using this model called MobileNet V2, which gives high accuracy, and also we use the callbacks and checkpoints, because upon giving so much of data that model is training and training, it sometimes may lead to overfitting. So that's why we have used this callbacks, where like a model checkpoint, like where the validation accuracy is not increasing, it has to stop, and also early stopping. Early stopping it is due to prevent the overfitting. So it accurately overfitting leads to biased type of output. So we have used this everything. So this is all about my both models of waste segregation identifier. Both works perfectly fine, and both gives the accurate results. And also in the future, I want to develop add some of features, like not to upload like image like this. So like I have to real time usage. Like how you can scan a product with your scan an item with your camera. So and it instantly gives the whether this is recyclable, hazardous, and everything. And also I want to add a user feedback loop, so that if a user scans item, if it is wrong, he can suggest that because I have given this, which is recyclable, which is organic, which is hazardous, and which is general in both the things. So based on this, the user can also say if somebody scans a bottle and it shows it is hazardous, so he can give feedback. Based on that, I can make the tune the model and train the model and retrain the model to give the best accuracy, and it will be a perfect model after so much of data and data. So this is all about our project. Thank you for watching my demo.